Hello everyone, welcome back to my channel. So this is a new video. I already said I'm going to make a videos on a digital circuits. So the topic which I first took is which is known as combinational logic circuit. So first of all we see the definition. Let us define this first. What is mean by combinational logic circuit? When a logic gates are connected together to produce a specific output for a certain specified combination of input is known as combinational logic circuit. Means what does it mean? You give some inputs and get some required output. So that is known as combinational logic circuit. It does not depends on the any stored data. Such that thing happens in the sequential circuits. So that is a future thing. We will discuss about that too. So this is a combinational logic circuit where you give a certain input and get a required output. So that is known as combinational logic circuit. So first we will study about some Boolean algebra terminologies. So here is a function known as f of ABC. So what? So this is a function. So there is a function. So what do you mean by a function? Function is something. Here it is a machine. Here one it is an input, and you get some kind of output. So here is an machine. So you think it as it is having an x square inside it. It is having an x square inside it. If you put 1, what you get? You will get 1 itself. If you put 2, what you get? You will get 4. So this is the function. So f of x is equal to x square. So this is what the function means. So now here is one type of function f of a b c. So this function depends on a b c. So here is an equation a b c plus a bar b bar c bar plus 1. So a b c is a common variable, but what does it mean by a bar b bar c bar? So a b c. So if a is equal to 1, so what does a bar will be equal to? A bar will be equal to 0. This is what does it mean? What is the difference between a and a bar? And here one it is an plus 1. So a b c are a variables and 1 is a constant, and a b c a bar b bar c bar are called as literals in a digital circuit terms. So this was a Boolean algebra terminologies. Now let us go for canonical forms. What does that mean by a canonical form in a digital circuit? Follows a specific pattern. That what does it mean? Meaning of a canonical form. So there are two types of patterns. That is, one is SOP, sum of a product. Let us see an example. So this is an example I have given here. So f of ABC means function of ABC means it depends on ABC. So this is an equation I have given. ABC plus a bar b bar c bar plus a bar b c bar plus a bar b c. So what does it mean? Sum of product. So these are a products. This whole 4 terms are a products, and we are making the sum of them. So this is known as sum of products. Next, one more canonical form is POS, that is product of sum. So function of ABC is equal to a plus b plus c and a bar b plus b plus c bar. So what does it mean? These two terms are sum and we are making the product of them. So this is known as product of sum. So let us take some more example, such as I can give an example is f of PQR. So the function depends on PQR. We can write it as PQR plus P bar Q R bar plus P bar Q bar R bar. So this is also is an one example of sum of product. And we can give one more example of product of sum, that is POS. So function of PQR equal to P plus Q plus C whole into P bar plus Q plus R bar. So this is one of the example. So that is what mean by SOP and POC. These are the standard forms in a digital circuits. So what do you mean by standard of SOP? So the standard of SOP means if there is some function, such as a which depends on a b c, if you write it as a bar b bar c bar plus a b c, so this is a standard form. If there is one more function which is also a b c and you write it as ab plus bc, so this is not a standard form. This is not a standard form, this is a standard form. What is the difference? You might be seeing some difference in it. What is the difference is that if there is a term like a bar b bar c bar a b c, a bar b bar c bar contains, so you might be seeing the difference is that a bar b bar c bar plus abc, here is a term which is having all the terms of a b c, that is it is having a, it is having b, it is having c. Let it be a bar b bar, it let it be a complementary term, but it is having the all the terms, and here it is also having a b c. But you might be seeing in this function there is a missing of c, and here is also missing of a. So this is not a standard form of SOP. Okay, this is not the standard form of SOP. The standard form is this. So now let us see for standard POC, product of sum. So let us write one function. I will take here PQR is equal to, it can have as many terms it want, there is no restriction for it, but the standard form that must contain all the literals. If one term is missing some C, B or something, that is not a standard form. So the standard form is this. This is not a standard form. Okay. Now next we will see the standard form of POS. So the standard terms POS is PQR plus PR. No, this is a POS, right? Product of sum. So we will write P plus Q plus R into P bar plus Q bar plus R bar. So this is a standard form. What is not a standard form? So this is standard form. Not a standard form means the example is PQR is equal to PR plus QR. No, I made again one time mistake. There is, it happens with everybody. P plus Q, it can't be seen here. I will write it here, or else I will write, no, I will write it here. So the not standard form example is, for this is for POS, P of PQR is equal to P plus Q and then Q plus R. So this is not a standard form example. This is not a standard form of POS. So now let us solve these examples. So here is an example which is not in the standard form of SOP. We have to convert it in the standard form. So before that I will show some properties. That is, one property is a plus a bar is equal to 1. You might be thinking how it is. If a is equal to 1, you take it as, for example, as a is equal to 1, then a bar will be equal to 0. So then 1 plus 0 is equal to will be 1, or else you can take it as a is equal to 0 and a bar will be equal to 1. So then also it is same, only 0 plus 1 equal to 1. So this is one property. One more property is a into a bar is equal to always a 0. How? If a is equal to 1 and a bar is equal to 0, 1 into 0 will be equal to 0, vice versa. So that's it. This properties you must keep in mind. And one more trick is that whenever you are converting an SOP into standard form, you have to remember that you have to use the 1. This you remember. And whenever you converting a one POS into a standard form, you have to use this 0. So let us try this one. So you might be seeing this is not a standard form because here B is missing and here C is missing and here is A is missing. So we have to bring them into this. So let us bring. I already told what this is an SOP form, means sum of product. So products are here and we are making a sum them. So this is a SOP form. We have to use 1. So how to use 1? So AC into 1 plus AB into 1 plus BC into 1. So this we have written. So as we know that what is missing in this term, that is B. So we have to bring the B. How we are going to bring the B? So A plus A bar is equal to 1. It means B plus B bar is equal to 1. So write it AC into B plus B bar plus what is missing here? C. So AB C plus C bar, and then what is missing here? A. So BC into A plus A bar. So we have written. Now let us multiply them inside. So AC into B is going to be ABC plus AC into B bar. So that is going to be AB bar C plus then AB into C, that is going to be ABC plus then AB into C bar, that is going to be AB C bar, then BC into A, BC into A is going to be ABC, then this is going to be A bar BC. So now you might be seeing all the SOPs are in the standard form. So now let us simplify it. I will bring it here. So let us simplify it. So we will simplify it as, you might be seeing ABC plus ABC, ABC plus ABC. What it is going to be? ABC plus ABC is going to be, don't think it has a 2 ABC, because in the digital form there is no term known as 2. So if A plus A comes, this is going to be 1 only, not a 2. Okay, so we will write it as ABC plus ABC will equal to be ABC only, means such as A plus A will be equal to A only. ABC plus ABC is equal to ABC, then A bar AB bar C, there is any term which is AB bar C? No. So write it as it is, AB bar C. Then ABC I have already minimized it, ABC bar plus ABC bar. Is there any such as term? No. So we will write it as ABC bar. The next term come again, it is a ABC, so just neglect it because already we have added ABC plus ABC plus ABC. So 3 terms of ABC will be concluded as only one ABC, that is it is going to be 1 only. So the next term is plus A bar BC bar. I have written it correct now here, A bar BC, only just BC it is, not BC bar. So the term is ABC plus A bar AB bar C plus ABC bar A bar BC. So this I have converted into a standard SOP form. The main term was this and I have converted it into this. So this is one homework I am giving here. So this is a homework. You solve it by yourself and check the answer. So that's it for today. In the next video I am going to bring the conversion of standard POC. So that's it for today. Thank you.